This is standard 8FA2. We're going to compare properties of two functions, each represented a different way. These are the four different ways they could be represented: as an equation, like a linear equation, as a graph, as a table of values, or as a description. Let's look at this first one. Letitia recently rented an office space and now needs someone to do weekly cleaning. She received these bids from two different cleaning services. Quick Clean. Now, anytime we're dealing with this, make sure that you label everything very closely. We're going to start with this Quick Clean. Quick Clean charges a $30 cleaning fee, a $30 cleaning supply fee for every visit, and $20 per hour. So let's write an equation here for Quick Clean, because this is just a description, and we're going to need an equation here for Quick Clean. Quick Clean. Our y, as we said, anytime we got a linear equation, y is equal to mx plus b. Our starting point, where we start, is for the $30. Even if there's no hours charged to you, you're going to pay $30 for cleaning supply fees. Okay, so y is equal to, now we need the rate of change, the slope, $20 per hour. That is your rate of change right there, $20 per hour. We're going to multiply 20 times the number of hours plus your $30, and that would give you your total cost for cleaning. Three friends cleaners. Okay, so this is three friends. Three friends. Three friends provide the table below to show its cost. And it's got several different costs. Let's see if we can write the equation on this one so we can compare them easy. Y is equal to mx plus b. I need a b, I need a starting point, but it doesn't give it to me for 0 hours. So let's find the m. We know our m is always equal to the change in y over the change in x. Okay, so here's our x, here's our y. Change in y. 25 minus 1250 would be 1250. Let's see. 1 minus 0.5, that would be 0.5. So if you divide 1250 by 0.5, your m would be 25. It's $25 per hour. That's your rate of change. Y is equal to 25x plus b. Now let's figure out what one b would be. If I'm going $25, down $25 each hour, from 1 hour to 0 hours, you subtract your $25, that would be 0. So your cost here is 0 for your b. Your b is going to be 0. Y is equal to 25 times x, and there's nothing for the b. Now let's answer the questions that we've got down here. We know that this one is three friends. I'm going to make it 3F to mean three friends. This one is Quick Clean. If it takes 5 hours for Letitia's office space to be cleaned, three friends is less expensive. Well, let's look and see. I want to put all the three friends things here. I'm going to put all the Quick Cleans over here. Let's check it and see. If it takes 5 hours, let's plug it into the equation. Three friends is y is equal to 25 times x, and here your x is 5, right? 25 times 5 would be 125. Okay, so it'd be $125 for 5 hours with three friends. Let's try Quick Clean. Y is equal to 20 times 5, or 5, plus 30. 20 times 5 is 100, plus 30 is 130. Who's cheaper? Three friends. It takes 5 hours. Three friends is less expensive? Yes, that would be true. Okay, and it says choose all that are correct, so let's try the next one. Three friends cleaners charges $5 more per hour, so we're talking about the unit rate. Well, let's see. Three friends charges 25 per hour. Quick Clean charges 20 per hour. So no, this is not right. Not right, okay? All right, if the cleaning costs for each company were graphed, the graphs would intersect where x equals 6 hours. Well, the graphs are going to intersect like we learned with systems of equations. The graphs will intersect when you've got a point where your x and your y are the same. If you had that situation, it would be right here. So what we're dealing with is a place where your x and y is the same, where equations are equal to each other. Let's try that. Y is equal to 25x. It's for one of them, right? And the other one is y is equal to 20x plus 30. We need to know where these two will intersect. Erase us a spot here so we can do this. I'll take QC off right here. And we'll try this right here. Both of these are equal to y, so we can simply say, let's get this set up so we can do it. $25x is equal to 20x plus 30. $25x is equal to 20x plus 30. We subtract 20x from both sides. And I've got 5x. I've got 5x is equal to 30. Divide both sides by 5. And I've got x is equal to 6. So yeah, it's at 6 hours that both of these are the same. Okay. If the cleaning costs for each company were graphs, the graphs would intersect where x is equal to 6. That's where they intersect. That's true. Let's go farther down here. We got a couple of others. If the cleaning costs for each company were graphed, the y-intercepts would be the same. Well, this one's y-intercept is 30. This one's y-intercept is 0. So that is not right. Okay, not right. Okay, if it takes 10 hours for Letitia's office space to be cleaned, 3 friends is less expensive. Let's compare the two here. 3 friends and quick clean. Okay. All right, 3 friends, quick clean. Let's go back and get the two equations. 3 friends equation is y is equal to 25x. Y is equal to 25x. And this one is y is equal to 20x plus 30. We're talking about 10 hours, so let's plug 10 in for each one. Y is equal to 25 times 10, which would give me 250. Y is equal to 20 times 10 plus 30. That would give me 230. Okay, so which one is least expensive, less expensive? The ones that less expensive is actually quick clean. The 3 friends is less expensive. That's not right, not correct. Okay, these are the two that are correct. Now, we're going to do another one where we're talking about comparing properties of 2 functions, each represented in a different way. Now remember, on the last one we did a description and we did a graph. This one we're going to do a table and an equation. So we can do one of each kind. The function P is equal to 17H plus 100 represents Kevin's pay per week, P, for 8 hours of work. Kevin makes $17 per hour, that's what it tells you here, and receives $100 to cover meal expenses. So $100 before he works any hours. Kevin accepts a new job where his pay is represented by the graph below. So let's put the equation for the old job here. Old job. P is equal to 17H plus 100. Okay. Now, let's see what they're going to ask us about the two. How did pays Kevin's pay changed from his first job to his second. So this is his second job, right? That's his old job. This is his new job. This is his second job. How does it change from the old job to the new job? Well, let's look and see what we've got. On the starting point, on this one we started at 100. He starts at 100 here. On this one he's making $17 per hour. Well, let's see how much he's making per hour. I know that he's making, in 10 hours, he's going up from 100 to 300. So he goes up $200 in how many hours? 10 hours. Our M is always our change in Y over our change in X, our rise over our run. In this case, that would be rise is 200 over the run, which is 100, or 10. 200 divided by 10 is 20. So now he's making $20 an hour, where before he was making 17. How does his pay change? Increases $3 per hour, right? Because he goes from $20 per hour to from $17 to an hour to $20 an hour, and that's $3 per hour more, right? Okay, now we have looked at how to compare two different functions, whether they're equations, graphs, tables, or descriptions.